Thank you, and good morning. So a little bit of background information, just so we're all starting on the same page. I have spent a number of years with many other developers working on the Tripal content management system. We use it to build websites and databases for biological data. It's very modular. We have lots of modules with particular expertise in genetic data and genomic data, also expanding significantly into breeding data right now. We have about 97 sites that report using Tripal as their base software. Some of these you might recognize. I have over to the right. My group works on the hardwood genomics project, but we do have developers in lots of labs. I guess I don't have to tell you about the benefits of a shared code base, having lots of developers from different groups, sharing the burden of development. And it has been quite a successful model. We do have an API. We try to do everything with good quality community standards and store all of our data in the Chatto database. So what I'm here to talk about, and what I hope you'll be interested in, is our Tripal Gateway project, which is an NSF grant. We're about halfway through, so this is more of a progress report than a final report. We have 5 main principal investigators, so I'm here representing the whole group. But there's 3 main components that we're developing. Web services for Tripal, which I won't be talking about, integration with Galaxy, which I will, and also improving data transfer, which I think will be relevant to some other people in the room. Just last week, we were able to announce the alpha release of Blend for PHP. This is basically a PHP wrapper for the Galaxy API. It's really similar to the BioBlend, the Python wrapper. It's not the entire Galaxy API, but it is a significant chunk of it. So now you can, from within PHP, manage users, launch jobs, build and run workflows. So a lot of that core functionality that you would want is there. It is available and free for anyone to use, and it has been posted on GitHub. It was originally on the Tripal GitHub, but last week when it went live, we were able to move it into the Galaxy project GitHub for other people, hopefully, to discover and use. This does come with Doxygen documentation, which should make it hopefully very easy to browse the classes and all of the documentation. So please check that out. So that was kind of that first big hump we had to get over to start developing what we really wanted to do, which is our Galaxy module. The code is rough, but it is on GitHub, so you can kind of track development as it's coming along. We do have an ambitious target date of releasing this this fall for all of the Tripal websites to be able to use. And basically, this is going to allow any Tripal website to provide a Galaxy workflow or set of workflows to their users. And our hope as community databases is we really want to ensure reproducibility of the data analysis and ensure standards that are expected by the community database are met, decrease curator time and effort, and also if we can provide the workflows within the look and feel of the site, we're hoping to capture a lot of our community users who may not know what to do with their data or how to analyze it, but they're coming to the community database, and if they have this new functionality, hopefully we can guide them to getting their data analyzed. So our goal is to have this to be able to be installed by any Tripal site once completed, but we'll be starting with the sites of the 5 PIs to start with. We have wireframed up and we have basic functionality for some of this that I'll show you. This is a very typical Drupal administration page. And so for our module, you would be able to go into the administrative backend of your website. And the first thing you might want to do is add a Galaxy instance. So we have a form. You can name your Galaxy server, provide the URL. We provide the option if you want to run all of the Galaxy jobs under a single user with its own, like one username and API key. You can specify it here, but you don't have to. You can also set it up so that each of your individual site users needs their own Galaxy username and API key. So we give that option. You can actually have more than one Galaxy instance and turn them on and off. So if one goes down and you want to use a different one, you can just use a little checkbox. And you can also manage workflows. So you may have a whole swath of different workflows to choose from, but maybe you don't want to expose some of them. So these would be automatically populated by our standard workflows. And you could go into the administrative pages, use a very nice graphical user interface to interact with those. When you install the module and it detects workflows that have either come with the module or that you've installed, it will automatically create a user input form. So it will extract the user parameters required to run that workflow and allow and build this sort of auto form where you can upload your input data sets and set parameters. The nice thing about doing this through Drupal is it's completely customizable from the regular Drupal administrative pages. So you can add parameters, you can set defaults, you can change the wording, so all of that's very easy. My group has been working on developing some of the basic workflows that we expect people to need. We are testing that. We have Galaxy instances at Washington State University, the University of Connecticut, and at the University of Tennessee. So we're testing it on all of those resources. The primary thing that we're hearing from our user community is they want to start with raw data. They're doing sequencing, and then they're immediately inundated with data, and they don't know exactly what to do with it. So we're starting most of our workflows from the point of you need to do quality control, and then go straight into analysis. We've had a lot of requests for resequencing alignment, variant discovery, and lots of transcriptome work going on, both de novo assembly, alignment to a reference, differential gene expression. So that's where we're focusing our efforts. If you want to follow along with workflow development or use any of our workflows, they will be submitted to the Galaxy, our new tools to Toolshed and our workflows, but you can also, we have a GitHub repo where we're posting them as we go. So one of the things when we wrote this grant that we realized we were going to struggle with is moving all of these huge data sets around. So Alex Feltus at Clemson University is our networking PI, and he's developed a new tool that has turned out to be quite handy called Big Data Smart Socket. It is a standalone client that maintains a metadata repository. And basically, the first step is to build an inventory of data sources relevant to a particular user community. So for us, we started with NCBI. We knew that we needed to know how to move data in and out of NCBI quickly. Cyverse is another big target for us. There's a lot of data living there. And our own Tripal sites where we're housing genomes and transcriptomes. So an admin would go in, perform experiments to determine the optimal method for data transfer for each of these data sources. And then this kind of curated transfer methodology stored in the metadata repository. And then when a user requests to do a data transfer, the client says, okay, well, I think I know the best way to transfer that data that's going to be fastest, and actually rewrites the query in the back end without the user knowing. It's pretty transparent. So this is a diagram of how we see all of these tools sort of working together. It starts when a user submits a workflow job on a Tripal site. The Tripal will compile a file manifest, like, oh, I'm going to need data from over here and over here. So it creates a manifest. The BDSS client steps in, says, do I happen to know anything about these data repositories? Do I know good ways to transfer that data? If it does, it looks that up. So some of the things it'll query, like HTTP is the default. That's how most people provide URLs. But it can also handle FTP, Aspera, SCP, curl, grid FTP Lite. And so we're adding more data transfer methodologies. The data transfer is actually performed back to the compute facility. And then the final step, the analyzed data, the output of the pipeline, is returned back to the Tripal site and then back to the user. So the BDSS software, also an alpha release, is available through GitHub. We also have a working implementation on the Washington State University Galaxy instance. So over under get data, it just says BDSS. You provide your URLs, You can also ask for parallel processes and hit execute. And that's going to get you, so this has only been integrated with Galaxy, not all the way back to the Tripal module. We're still working on the Tripal module. But it seems to work pretty well. Here's our test case, transferring 871 megabases of NCB SRA data. We tested this last week. If we use the regular upload script, it took about 2 minutes. If we selected the BDSS client, it rewrote the query on the fly as an Aspera query instead of an HTTP query. And that resulted in a 2.9x speedup. So that just looked in the metadata repository and understood, okay, I know how to translate that HTTP link into an Aspera request. That's much faster. I should do that instead. So that's working pretty well. So here is our ongoing work. For Galaxy integration, there's a long way to go. We're still working on improving those web forms so that the workflow is automatically turned into a nice submission script or submission form. We're building a dashboard for site administrators and for users to monitor workflows and obtain results. We are still having debates about how to handle visualization, how to handle both soliciting and providing provenance information for the data that we're moving around. Probably going to do CloudMan integration, so we have not done any of the PHP bindings for the CloudMan API, but hopefully that'll get done this fall, which will be great for triple sites to be able to launch cloud instances or connect to cloud instances of Galaxy. On the data transfer side, the Feltus Lab is continuing to work with the BDSS, integrate that with the Triple Galaxy module. And they're also exploring software-defined networking, which is one of those hot new buzz terms. I don't know a ton about it, but they're ordering open flow switches for all the triple sites, and they're all going to have really awesome software-defined networking, or so I've been told. So hopefully that will come to fruition. We're thinking in the next 6 to 12 months. Once all of this is done, we'll install all the tools on our first set of target triple sites, but everything will be available for the community to use. So that's our progress report for this grant. As I mentioned at the beginning, I'm representing a whole lot of different people who have worked on this and are continuing to work on it. Stephen Ficklin is the main PI from Washington State University. He's not here today, but he will be for the GMOD meeting on Thursday and Friday. Also the University of Connecticut, Jill Wegerson, Clemson University, Alex Feltus, University of Tennessee, my lab, and the University of Saskatchewan, Lacey Ann Sanderson, who is one of the core developers of Tripal. So with that, I will take any questions you guys have.
Okay, we have time for a couple of questions.
This might be already a small problem. Do you have modules to basically export from Galaxy to Chado so that it can appear in your database?
Yeah, so that's the goal, and we're still sort of writing that. And one of the things is where to insert the curator step. Somebody looks at this and makes sure it's appropriate for the database, and so either we'll export it straight to Chado, and then a curator will look at it and then put it in our triple Chado, or I guess we're all nervous about just letting users dump it straight into Chado without the curation step. But so once we get the curation step figured out, yes, that's the goal, to write everything. Primarily, like I said, focusing on RNA-seq and DNA-seq and just getting those as features into Chado. Yeah. Oh yeah. Okay. He was asking about integrating the data into Chado.
So my question is about the data transfer. You mentioned in your slide that you transferred 800 something megabytes,
right,
and it took 120 seconds. So were these, where are the end sites, and were the files smaller number of files, or like one large file?
It was just a few just a few files. And that was just sort of a quick and dirty test case, so I had something to show that it works. But so we're scaling that up and trying to test bigger and bigger data sets, because that's a unrealistically small data set. But yeah, just a few files. But
okay. Just, I'm former network engineer, so you were getting very, very low transfer rate. I mean, should be much better.
Right, right. And so that's been interesting to do, to have people sitting down and testing the best ways, and it's actually quite time consuming. But we're hoping if people sit down and do it and then put the best methods into this metadata repository, that it'll be better in the long haul for all of our data transfers. Yeah.
Thanks.
So this is pertaining to Aspera for Galaxy. Can we get this feature upstream and hidden from the user?
Can you get it what?
Can we get the Aspera feature upstream and hidden from the user?
Yeah, so I think that's feasible, absolutely. So the BDSS, I think you could, I mean, you can go get it right now and install it on your Galaxy instance, and just, oh, I don't know, I assume the metadata repository would come with it, and then it would know to use Aspera, in particular with NCBI. You might have to code it for any other sites that have Aspera enabled. But yeah, I can talk to the networking guys about having just an Aspera plugin by itself without the BDSS part of it. So, yeah.
One very general question. So your very first slide showed a lot of databases that dealt with specific organisms.
Absolutely, yep.
And so as somebody who works on a model organism myself, quite concerned about the fact that NSF and NIH are kind of pulling away from wanting to fund these databases for model organisms. So just as a really, really broad sort of question, so how do you see these sorts of efforts helping to bridge the gap that's going to happen when the major funding agencies pull away from these things? I think the general notion is that the users will somehow rise up and take care of it themselves, but it's not really clear how that is going to happen.
The tear model, right?
Yeah,
We're going to go to a
somehow
subscription.
it will all just work itself out. So you have thoughts on how this might work and how efforts like this might contribute?
Yeah, that's a really good question. We have had reasonably good success over the past 5 years of going to NSF and USDA as a collaborative of many of these model organism databases. And so they seem much more interested in funding tool development if it will benefit many different crops and species. So that's been our model. That does not get you curation. That does not give you the person who's digging through the literature and shoving all the data into the database. And a lot of these groups have gone to development is funded at the federal level. Curation needs to be funded at the industry level. This is, of course, assuming you have a functional industry that has money to throw around. We haven't seen a ton of that in hardwood trees. It's a big industry, but not as big as a lot of our commodity agricultural crops. So, yeah, I don't know the answer, except that the more people we get involved to go into these grants, the more successful they seem to be. So. All right, thank you.
Yeah, thank you.